So the next topic we're going to be covering today is binomial expansion. So the reason we use binomial expansion basically is a quick way of expanding out an expression. So if, for example, you had something like p plus q to the 6, so obviously we know p plus q to the 6 means p plus q multiplied by itself 6 times, and we can write it out like that, but it's just going to take us a bit of time to multiply out, so it's going to take, you know, a couple of minutes definitely at least, but we can do it, but there's just a quicker way of doing it by using the expansion formula in the table. So we're going to actually do this as an example. We're going to use the expansion formula and just do it out a little bit quicker as opposed to multiplying everything out. So example 1, as I said, we're going to expand p plus q all to the 6. Okay, so the formula is in your log tables and it looks something like this. So it's x plus y to the all to the n is equal to nc naught x to the n y to the naught plus nc1 x to the n minus 1 y to the 1 plus nc2 x to the n minus 2 y to the 2 all the way up as far as n cn and x to the naught and y to the n. So it looks a little bit scary, but again, you know, don't worry, it's very, very doable. We'll go back here to the p plus q bit and I'll explain exactly what letter corresponds with what. So just to explain then, this p bit is your x term, the q bit is your y term, and then this number up here, your power, is your n term. Okay, so we're going to fill it into the formula and that'll expand it out for us quickly, quite quickly. So we've got a 6c naught, okay, and then we've got an x to the n, so it's p to the 6, because n is 6, and y, which is q to the naught, plus 6 NCR1. We've got a p, n minus 1 is just 6 minus 1, which is 5, and q to the 1, plus 6c2 is p to the 4, and q to the 2, plus 6c3 is p to the 5, no, p to the 3, sorry, excuse me, and q to the 3, we're still going up, plus 6 to the 4, and then that's p to the 2, and q to the 4, plus, I'll just have to go down to the next line, we've got 6 NCR5, p to the 1 and q to the 5, and last one plus 6 NCR6, p to the 0 and q to the 6. So just to explain, again, you can see quite clearly 6 NCR0, 6 NCR1, 6 NCR2, all the way up as 6 NCR6. It starts with p to the n, so p to the 6, which is x to the n, and it goes all the way down until you get to p to the 0. Opposite to that then, we have q starting at 0, going all the way up until we get to n. Now, what you just have to be careful of here, ladies, is just multiplying out, so just to kind of clear up your terms basically. So we're just going to get a calculator. Okay, so if I go to my calculator here, how I do 6 NCR0 is just 6, and then we have shift, your divide button, so you can see it's a C, and 0 and equals. So that's a 1. So you just pop that in there, 1. So this is our next line down, p plus q to the 6. Then we've got a p to the 6, which is just p to the 6. So it's 1 by p to the 6. And then q to the 0, anything to the power 0 is just 1. We keep going. So 6 NCR1, which is 6. So it's 6 by p to the 5 by q to the 1, which is just q, plus, again, 6 NCR2, which is 15, plus 15 by p to the 4 by q2 to the 2, plus 6 NCR3, which is 20, so it's 20 by p to the 3 by q to the 3, plus, I'll have to go down to the next line, so it's 6 NCR4, which is 15 p squared q to the 4. The next one is 6 NCR5, which is 6 by p to the 1, which is just p q to the 5. And the last one, 6 NCR6, which is 1 by p to the 0, which is 1 by q to the 6. Okay, so we can tidy that up just slightly. Let's try and get it all on one line. So p plus q all to the 6 equals, that's just p to the 6. Okay, 6 by q by p to the 5 plus 6p5q plus 15p to the 4q squared plus 20p cubed q cubed plus 15p squared q to the 4 plus 6p q to the 5, and last one, 1 by 1, q to the 6, so it's just q to 6. Notice that if our n is 6, we will have 7 terms in our expansion.